Hello everyone, myself Sahana. I'm studying in Sri Venkateshwara College of Engineering in IC Department 4 and my topic is about cyber physical systems and microcontrollers. Firstly, contents. Introduction to cyber physical systems and microcontrollers. Components of cyber physical systems. Design of cyber physical systems and microcontrollers. Microcontrollers architecture for industrial cyber physical systems and benefits of cyber physical systems and microcontrollers. Applications of cyber physical system. At last, conclusion. Firstly, introduction about cyber physical system. A cyber physical system CPS or intelligent system is a computer system in which a mechanism is controlled or monitored by computer based algorithms. Tightly coupled cyber and physical systems that exhibit this level of integrated intelligence are sometimes referred to as a cyber physical systems. Firstly, in cyber physical systems, physical and software components are deeply intertwined, able to operate on different spatial and temporal scales, exhibit the multiple and distinct behavioral modalities, and interact with each other in ways that change with context. CPS involves transdisciplinary approaches merging the cybernetics, mechatronics, design and process science. All CPS have computational process that interact with physical components. These can be relatively simple, for example, heater like cutting machine, or comprise multiple components in complex assemblies. For example, vehicles, aircraft systems, oil refineries. The computational and physical process of such systems are tightly interconnected and coordinate to work together effectively, often with humans in the loop. This trend does not remove the importance of human involvement but does change roles and requirements for new skill sets. Furthermore, as CPS become more dependent on computational processes, it becomes increasingly important that they be engineered to be reliable, secure, and safe. Further, scientific and engineering advances that extend the connectivity of this system and deliver the greater reliability could open new opportunities to take advantage of the unique properties of CPS. And what are the components of cyber physical systems? Here we come to know that the cyber physical system is interconnected with the Internet of Things, the Internet embedded systems, and wireless sensor networks for also the mobile networks, at last even for satellite networks. Here, science and engineering foundation, system performance, quality and acceptance, applied development and deployment, workforce for continuing innovation in CP. The design of cyber physical systems and microcontrollers. In recent years, there has been a confluence between different fields addressing the broad field of cyber physical systems. Traditional 8-bit microcontroller based systems have become more capable and frequently feature 32-bit processors with networking capabilities, thus overlapping larger OS based systems. Single board OS based computers have shrunk to credit card size and prices on the low end have dropped substantially to overlap the application domain of microcontroller systems. And thirdly, mobile platforms also share many characteristics of these systems and overlap their design and application domains. These systems each have their own design communities, tools, and standard approaches. However, their commonality and overlapping application domains indicate that they share common design problems. The evolution into newer applications area also bring new problems. The situation become more complex when these systems are integrated into a large diverse systems. The design approaches and design problems for these systems of embedded system are revived by overlapping and non-overlapping characteristics and design issues are being analyzed. Here, microcontroller architecture for industrial CPS. Here we can see how the cyber physical system has been interconnected with the Internet of Things, cloud storage, and for real-time visualization. How we can increase the performance of this CPS? The main methods of increasing the computational performance of processors in embedded systems and the latest approaches is used in computing such as heterogeneous computing and increasing the number of processor cores for parallel execution of operations are being considered. The issue of security of cyber physical system is in the post-quantum era and methods of hardware implementation of quantum-resistant encryption algorithms based on the lattice theory that meet performance and security requirements are considered separately. Methods for improving the reliability of embedded systems and expanding the functionality using field programmable gate arrays are also described. The advantages of using the RISC-V means reduced instruction set computer core architecture for embedded systems are also considered. Based on the requirements, a controller architecture based on RISC-V is proposed, which uses the principle of heterogeneous computing to increase the performance and meeting the requirements of modern equipment for industrial cyber physical systems. Next, benefits of the cyber physical system. The development and use of advanced CPS will generate the unique opportunities for economic growth, create the skilled jobs for the long term, and help ensure the health, safety, and security of the nation while improving the quality of life. The CPS are drivers for innovation in a broad range of industries and can lead to a new products or unlock the new markets. By the end of the decade, the embedded networking and computing components are projected to account for more than half of the value that share in the diverse sectors, including the automotive, consumer electronics, avionics, and aerospace, manufacturing, telecommunications, intelligence buildings, and health, and even for medical equipment. A recent report estimates that the technical innovations of CPS could find direct application in sectors accounting for more than the dollars of 32.3 trillion in economic activity and with the potential to grow to dollar of 82 trillion of output by 2025, about one half of the global economy. Here we can see the examples of cyber physical system such as the robots, intelligent buildings, implantable medical devices, cars that drive themselves, or the planes that automatically fly in a controlled airspace. These are the examples of CPS. Today, CPS can be found in such diverse industries as aerospace, automotive, energy, healthcare, manufacturing, infrastructure, consumer electronics, and info communications. What are the applications? Here, the common applications of CPS typically fall under the sensor-based enabled autonomous systems. For example, many wireless sensor networks monitor some aspect of the environment and relay that processed information to a central node. Other types of CPS include smart grid, autonomous automotive systems, medical monitoring of our process control system, distributed robotics, recycling, and automotive pilot avionics. A real-world example of such system is distributed as Robot Garden at MIT, in which a team of robots stand a garden of tomato plants. This system combines the distributed sensing, navigation, manipulation, and even for wireless networking. What is conclusion? The potential of CPS to change every aspect of life is enormous. The concepts such as autonomous cars, robotic surgery, intelligent buildings, smart electric grids, smart manufacturing, and implanted medical devices are just some of the practical examples that have already emerged. These systems all rely on a computational core that is tightly conjoined and coordinated with components in physical world. Robust, effective design and construction of systems and infrastructure is to be key to be designing dependable systems from the ground up and reducing cost and time to market. Improved performance and quality assurance essential for spurring the future investment, acceptance and use of innovative systems that promise to provide revolutionary improvements to conventional practice. Thank you.